All right, so have you guys seen this image? This is blowing my mind.
Proxima Centauri b.
Yeah.
It's like everyone's talking about it, and for good reason. The James Webb Telescope. I mean, come on. It's like we're one step closer to knowing, like, is there life out there?
It's huge.
It is huge. Okay, so we're going to dive into all of this, but
Yeah.
Proxima Centauri b, why is this particular exoplanet so important?
I mean, we hear about these exoplanets all the time, but this one's special.
Right.
This one's in the habitable zone
That's right, the habitable zone.
of the closest star to our sun.
Okay, so explain that.
Yeah.
Because, I mean, how close are we talking, first of all?
So Proxima Centauri is our nearest stellar neighbor. It's a red dwarf star, which means it's a lot smaller and cooler than our sun.
Okay.
It's only about 4 light years away.
Okay, so light years, that's still pretty far, right?
It is. In terms of like our current technology, it would take us tens of thousands of years to get there.
Yeah.
But astronomically speaking, that's right next door.
Okay.
So, and then when we say that Proxima b is in the habitable zone, that means that it orbits its star at a distance where temperatures could be just right for liquid water to exist on the surface.
Okay.
And that's a big deal.
Huge. Huge. So, I mean, we're saying liquid water, we're thinking like
Essentially, yeah.
life, right?
Yeah.
This is big stuff. Okay, so back to the image itself.
Right.
What are we actually seeing here, and how did the James Webb Telescope even capture this? Because it's not like your average telescope, right?
No, not at all. I mean, this thing it's a marvel of engineering, really. So the James Webb Telescope, it sees in infrared light,
Okay.
and that is key here. Infrared light, it can cut through the dust and gas that obscures our view in visible light.
Mm-hmm.
And then they use this instrument called a coronagraph. Imagine like a little sunshade, right?
Okay.
It blocks out the light from the star, Proxima Centauri in this case, and that allows us to see these much fainter objects around it like Proxima b.
So you're saying we wouldn't be able to see this planet without that, like, that special technology on the James Webb?
Not with this level of detail, no.
Wow. Okay, so we have the image. What's it look like? I mean, are we talking like high resolution? We're seeing mountains and rivers. What are we looking at?
So we're not quite at mountain and river resolution yet. What we see is a dot,
A dot.
a faint dot of light.
Okay.
But that dot, that's Proxima b.
Okay, so just to be clear, it's not like a photograph,
It's not a photograph.
Oh, yeah.
It's more like, if you were to look at a really bright light bulb and you see a little speck of dust
Right.
right next to it. That's kind of what we're talking about.
Okay, so it's a dot.
It's a dot.
But it's a really important dot. What can scientists actually tell about the planet from just this, this little dot of light?
So much. It's incredible.
Mm.
So by studying how the light from the star dips slightly as Proxima b passes in front of it, they can actually determine the planet's size really accurately.
Oh.
And from there, they can estimate its mass, its density. They can learn about the planet's atmosphere by analyzing how the starlight passes through it. And they can map its orbit precisely.
Okay, so it's like detective work.
Makes sense.
Using light. Amazing.
Yeah.
But how do we go from a dot to like, okay, maybe there's life there? What else makes Proxima b a good candidate for, the big question?
Right. So we talked about the habitable zone.
Yeah.
Right. And that's key because for all we know, life as we understand it requires liquid water.
Right.
Proxima b's position, it's in the sweet spot, right? In that Goldilocks zone.
Yeah.
Not too hot, not too cold. And from the data we have, it's possible that Proxima b has a dense atmosphere, and there are hints, and these are just hints of water vapor.
Which is huge. Okay, so maybe an atmosphere, maybe water. I mean, that sounds promising, but
It does.
what about the star itself? I mean, you mentioned it's a red dwarf. Those things are known to be a little feisty, right?
They are. Red dwarfs, they can unleash these intense flares, like way stronger than anything our sun produces.
Okay, so like solar flares on steroids.
Exactly. And we're talking bursts of energy that could potentially strip away a planet's atmosphere over time, bathe it in radiation.
Wow. Okay, so it's like this double-edged sword.
Yeah.
Right? It's like, oh, maybe there's life, but also, oh, maybe that life would get completely obliterated.
Yeah. It's a balancing act for sure.
It's fascinating, though. It's like, what could possibly survive in those conditions? And it really makes you wonder, like, how tough does life have to be to make it out there?
Right.
So much we don't know, but this image, I mean, it's just the beginning, right?
Absolutely. We're just scratching the surface. We have so much more to learn.
This is why I love space. It's just full of mysteries, this one little dot, and we're all suddenly wondering if we're alone in the universe.
It's amazing, isn't it? I mean, the James Webb is just getting started.
Yeah.
Who knows what else we're going to find out there?
Right. Okay, everyone listening, I want to know your theories. Hit us up on social media. Is there life on Proxima B? Or is it just a matter of time before a massive flare wipes everything out? Let us know what you think.